Hi everyone, this is K1 from E section. So today I want to discuss about the time domain description of a singleton modulation under the subject of analog and digital communication. So let's getting into the topic. So coming to the modulation definition of a modulation, in general we have to transmit the low frequency signal, which is message signal, to very large distance, but it doesn't possible because there is a loss of power and information due to the natural distraction. So in order to transmit the message, our message signal to the long distance, we use the technique called modulation. In this technique, our low frequency signal, which is modulated with the high frequency signal called carrier. So low frequency message cannot be sent over an airwave medium. So the low frequency message can be converted into high frequency signal for the purpose of airwave communication. So this conversion process of a low frequency message signal to a high frequency signal is usually accomplished by modulating or changing a high frequency signal using a low frequency message signal. So by the definition of a modulation, here the characteristics of a carrier signal like amplitude or frequency or phase angle changes according to the our message signal, which is very low frequency signal. So the high frequency signal can be modulated by changing its amplitude, frequency or its phase, as we said. So here you can see the pictures of a different modulation technique like amplitude modulation, frequency modulation and digital modulation. Coming to the amplitude modulation, here the carrier, which is high frequency signal amplitude, is changed according to the envelope amplitude of a input signal. So here you can see the resulting signal where the it is a high frequency signal, but amplitude is similar to the input signal. And similar to the frequency modulation, here the frequency of a carrier signal changes according to the input signal. So where the amplitude of a input signal is high, our carrier frequency is high, and if the input signal amplitude is minimum, carrier frequency is low. So and coming to the digital modulation, here we transmit the binary data using the carrier sinusoidal wave, where the on period, which is 1 bit data, having the high frequency signal, and off period, which is 0 bit, we have low frequency signal. So these are the compressions and rate fractions of a carrier made according to the input signal. So these were the 3 modulation techniques, and we can find many modulation techniques we generally use. So but what is the need of modulation? Like as we see amplitude modulation, frequency modulation, what is the difference and what are the advantages by doing this signal? So here you can see the some needs of a modulation, like practical length of an antenna decreases. If the percent of a modulation increase, there is no use of long length antennas. Like if we see in olden days, we can see the antennas for the small mobiles, but here antenna of a smart mobiles decreased to very small length. It is because of improvement of a modulation technique and narrow bandwidth of signal, and with clearness of a signal and frequency multiplexing, where we transfer many frequency of signal in one channel, and effective power radiated by antenna. So these were the some needs of a modulation, not daily life. So but what are the types of modulation generally we do? Like amplitude modulation, frequency modulation, phase modulation, which is also known as angle modulation, and singleton modulation, and multi-tone modulation. As for the topic now, we discuss only about the singleton modulation and amplitude modulation with singleton modulation, and frequency modulation with singleton modulation. So let's getting into the topic, our singleton modulation. But what is single tone modulation, or it is also called as tone modulation, where a modulation in which only one frequency message signal is modulated with the carrier signal by a frequency tone signal. So the tone which is single frequency modulation signal consists of only one frequency component, and the signal is modulated with a carrier signal. So here you can see the pictorial description of a single tone modulation. Like left side you can see message signal, which is single frequency signal and carrier signal, and the resulting modulated time domain signal. And here you can see the frequency spectrum of these signals, like which after modulation these frequencies were divided into left side and right side, and amplitude were differentiated. So coming to the time domain description of a single tone modulation in different ways, like we have amplitude modulation, frequency modulation, and phase modulation. Coming to the first single tone amplitude modulation definition. So amplitude modulation in which the modulating or baseband signal consists of only one signal frequency, that is modulation is done by a single frequency or tone. So this type of amplitude modulation is known as single tone amplitude modulation. So here you can see the general expression for the message signal, which is x of t equal to Vm cos omega m of t, where Vm denotes the amplitude so, and carrier signal is a cos of, so c of t is equal to a cos omega ct, which is carrier. So for the general expression of a am signal is denoted by s of t equal to a cos omega ct plus x of t cos omega ct, where x of t denotes the input message signal. By substituting this x of t in the equation 3, we get the resulted equation as a s of t equal a cos omega ct plus Vm cos omega ct into cos omega mt. So by doing some calculation, we get the s of t equal to as equation 4. So from above we get modulation index of in amplitude modulation is given by maximum amplitude of a signal to the amplitude of a carrier. So here maximum amplitude of a signal is denoted by x of t max by a, which is known as amplitude modulation index. So coming to the relating calculation, where s of t is equal to a cos omega ct plus a into m of mf by 2 into 2 cos omega ct plus cos omega ct plus. So after doing some calculation, we get the final equation as a cos omega ct plus a dot mf by 2 into cos omega c plus omega m of t plus a dot mf by 2 cos omega c minus omega t plus t. So here omega c and omega m denotes the angular frequency of a message signal and carrier signal. So equation 6 reveals the AM signal as 3 frequency components as follows. Like in general, we have the upper sideband, lower sideband, and frequency signal in the frequency domain spectrum, where upper sideband represented by omega c plus omega m, which having the amplitude a dot ma by 2, and lower sideband omega c by minus omega m having amplitude a dot ma by 2, which they have same amplitude in the frequency domain spectrum. So here you can see this frequency spectrum of the time domain equation of our amplitude single tone modulation signal. So coming to the single tone frequency modulation, the single tone frequency modulation, that is the modulation signal h of t, we assign the signal of the amplitude em and frequency fm. So x of t equal to em cos 2 pi fm of t, and the unmodulated carrier is represented by expression c of t equal to ec cos So the unmodulated carrier is represented by the expression C of t equal to E sin omega ct plus phi. So from the above equation, by doing some calculation, we get the frequency deviation expression like delta f equal to k into fem, which is called as a frequency deviation. And for the calculation of angular velocity of a fm wave is given by this calculation, where we get the angular expression as a omega ct plus delta f into sin omega t by fr. So by after modulation index is given by frequency deviation by modulating frequency, which is known as fm m of f equal to delta f by fm, and deviation ratio as maximum deviation and maximum modulation frequency. So coming to the percentage of modulation of FM wave is given by actual frequency deviation by maximum allowed deviation. So these are the parameters we conclude from the singleton modulation, and we have discussed the time domain descriptions of a amplitude modulation of singleton modulation frequency signal and frequency modulation of singleton signal. So thank you.